What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we are going to be going over converting the rest of our super or special camera from blueprints to code. So in the previous episode, we converted lots of our logic to create a special camera, is what we're calling it now, but it's converting our super camera. We need to fill out the rest of the logic in there, and then do a little bit of logic in our regular camera to reference that special camera after we convert it. So that's what we're going to be covering today, but otherwise you should see everything exactly the same as you have been seeing it with your supers, because it should be exactly the same as it was in Blueprint, just a little bit more accessible and easier to edit after this episode. So with that out of the way, we can go ahead and get started. If you're interested in getting caught up in the series, you'll be able to see things like our hitboxes, our throws, our multiplayer setup. All these things, they're all in this playlist in the top right corner right here. I highly recommend watching it if you're interested in the series. Alternatively, if you're not interested in the whole series and you just want to see how to make a C++ camera for a fighting game that supports super moves and cinematic movements, then feel free to check out this episode right here in the top right corner, which is the first episode where we created the super move, which is our initial implementation of the super camera as well. And so if you watch that one, you'll be able to follow these episodes one to one. Now this is a code and blueprint tutorial series, but since we're converting from blueprints to code, we're going to be taking blueprint logic and doing all of the new logic in our code today. So first things first, we need to go to our blueprint. So blueprint, functional BPs, cameras, and it is now called the base special camera BP. We want to go in there. Now when we come in here, we have two events. We have swap to super camera view and swap to victory camera view. Now we actually created both of these events as functions in the C++ in the previous episode, so we're going to be filling out these events today. So now we're in the code and we want to go to our base special camera.h. This is the file that we made in the previous episode. And in here we already have our functions that we have as events in the special camera. So swap the super camera view and swap the victory camera view. But we want to update these today because we noticed that the swap to super camera view event takes in a character reference, which is a fighter template character object reference. And we weren't doing that in the code class, so we can update this. A fighter template character pointer character. Now to actually access this type, we will need to add an include. Make sure you add it above your generated.h include here, otherwise you will get errors in your file. And we're going to include fighter template character.h. Once we do this, we have to update the CPP file as well. So a fighter template character pointer character. We add that to our swap to super view here. And now we're good to go. We can start converting our logic. So let's go back to the blueprint. So the first thing we were doing was checking to see if the character reference was equal to player 1 reference. If it was, we were determining that we were going to use player 1 ref for a lot of our logic. Otherwise, we were going to use player 2 ref. But honestly, there's no reason to do this. We were using it to determine if they were facing right and then place the camera at the appropriate spot. We can place it on the right side and place it for the right character by just knowing this character reference. So we're going to skip this initial part right here. We don't need to do any of this. And really, we don't need this entire section here. So everything that's highlighted is going to be omitted from the code because we don't need it. So we're basically just going to handle this logic right here. So going on to this logic, if it was player 1 in the blueprint, we were checking for validity, and then we were checking to see if they were facing right or left. So let's do this now. In swap to super view, we're going to check if character. So basically, if this character is valid, if this pointer is not null pointer, we have an actual character to reference and utilize here. Then we need to determine what direction character is facing. So if character get is facing right. This is a getter or an accessor that we've set up in our character class to just return the is facing right boolean. So instead of grabbing it directly like we were doing here, we're using this function for it. If this returns true, the character is facing right. If it returns false, they're facing left. So we can add an else on here. These couple lines here cover everything that you see right here already. So all we have to do now is figure out the logic inside the if and inside the else. Let's start with the if logic. That's the true result of the branch here. We use our character reference and get the actor transform. Then we modify the location directly on here and pass everything back into a new transform that we're setting for this camera. Now you'll notice we don't use the rotation values or the scale values when grabbing the player's transform. And so we don't need to get the entire transform to do this. we can simply grab the actor's location. So if we go back into the code here, we can add this character get actor location. And we can set a value equal to this if we want. So f vector, and we'll call it character location, equals character get actor location. Now we're going to need to do this in both the if and the else, so we can actually simplify this logic more from what was in the blueprint, where we were doing it in both the true and the false of the branch, and just put this outside of this if statement. So if we take this line, put it as the first line in the initial if statement, if there's a valid character, we don't need to do it inside the if or the else. Now, based on the direction that we're facing, right or left, we were modifying the location a little bit. In my specific example that I made for the mutant, I chose these values. Now, if you wanted to add rotation or scale, you could use get actor transform here and pass these values into the new transform. I'm just not doing that here. I'm arbitrarily picking these values. So you can customize this to your liking. Just to follow our example directly, though, we can take our character location and grab appropriate values, so .x for example, and we were subtracting 200 here because the character was facing right, and we decided that subtracting 200 was a good value. We were subtracting 200 here because this is our x value, so this is the distance from the character in terms of depth, so how close to the screen or farther away from the screen the super camera is going to be compared to the character. And so we're going to say character location .x minus equals 200.0f. Then we're going to go character location .y, and we were adding 125. This is the horizontal location, so we're offsetting that a little bit. Plus equals 125.0f. And then character location .z was just a flat 0, so plus equals 0.0f. In this case, I don't really have to do anything with this value. So to make it even easier, if you don't intend to modify it, you don't need to include this line. And then you could do the same thing in the else statement, but we have to change the values. So if we're facing left, which means is facing right returns false, we were subtracting 200, same distance x, but then we were adding a negative 125 or subtracting 125 so that the offset was the other direction. So the only change here would be this. These are hard-coded values for all characters right now. When all characters perform their super, it's going to do this exact same thing. Really, every character should have their own super. That very well may adjust the camera to a specific spot for that character. So if I'm the mannequin, I do one set of location, rotation, and scale changes. If I'm the mutant, I do another. So the character should have this information. Or the camera should have this information, and it should know the values for each character. This is something we will get to. We're not going to cover it in today's episode because we're just converting it, but just note that's why we're setting it up this way. And this is something that should be adapted to be more dynamic for our characters. At this point, we have our offsets for our player location, and we can go ahead and set the actor transform on the super camera or our special camera to the spot we actually want it to appear at. This is really simple. We go back into our code and we're going to call set actor transform, and it needs to take in an f transform. Now f transform can be filled out with a rotator and two f vectors. Rotator is the rotation, f vector 1 is the location, f vector 2 is the scale. So to do this, we can say f transform, then f rotator, comma, f vector, comma, f vector. So first one, rotation, we can follow that by using the rotation values that we hard-coded in here. So 0x, 0y, negative 30z. Simple enough, we can write this directly, 0.0f, 0.0f, negative 30.0f. Next one is our location, which is going to be our character location. We directly modified that variable, so we can just pass this in directly. We actually don't need to say f vector here. We can just say character location. And last one is the scale. Now for this, the scale is completely 1, so you have a few options here. You can do a 1 vector. You could manually pass these in as 1.0f. You could use the current scale. We can just do f vector colon colon 1 vector. And so this will return f vector that literally looks like, that's exactly what we want. So there we go. That's our actor transform. Now, if we changed it for the flip side, so if we're facing left, we want to make sure we represent this here as well. So we go back into the code, and we call set actor transform. We're going to make another F transform, F rotator, 0.0F, 0.0F, 30.0F, because that's what it is in the left branch, right? If is facing right returns false, we're just setting straight 30 on the yaw. We're still going to just use character location, and for the scale, it's all 1.0s, so we can use one vector yet again. Now note, these are so close together, we don't need to do these in separate branches. We can clean this up further, just like we did with the regular camera. But remember, I'm just converting right now. We'll do cleanup in the next episode when this class that we're creating is finalized. And then afterward, we are setting the camera components field of view. So a camera by default has a camera component, which is a camera component called camera component. And I'm not joking. You can see it right here in this little pop-up. So the camera component is something that all camera actor children have. And so we can just access this by searching get camera component. And we will get that object right there. Now you'll see I put this below the if and the else statement because it is going to be the same node regardless of what path we took in that branch. So we're going to be setting the field of view to a solid 65. Arrow set field of view, and we're passing in a manual 65.0F. Now once you try and do this, you'll get error about the type that's being used because we're trying to use a U camera component, which we haven't included, but we can simply go up to the top, include camera/camera component.h. That will make this type known to this class, and then we can use it right here. Now, excellent. This is a proper conversion from our blueprint event to the code, so you can feel free to delete everything that's in this swap to super camera view event. Gone. It's fully converted. Now, the victory view is very, very similar. We're going to take in a character reference. We were checking if it's player 1 or player 2, which we don't need to do in the code anymore. We were checking to make sure the character was valid. Checking if they were facing right or left. Changing the transform based off of this. Setting a new transform for the super camera. And setting the camera's field of view. So if we go back into the code and go back to base special camera.h, we pass in a fighter template character pointer called character. And we go back to the CPP and update this function, swap the victory view, takes in a fighter template character pointer called character. We can literally copy this logic, everything inside of the other function. Now the only things we need to change are the location values and the transform values. Those are the only things that were different between these events in the blueprint. I still recommend keeping them as separate functions in the code because we can set variables for the super camera locations for each character type, victory camera view locations for each camera type, and we can access them in these functions. You could combine it into one function and just pass in the appropriate values, but I'm going to keep them separate. So in here, we have our get actor transform, and we were subtracting 0 on the X, so same that we're used to seeing, adding 600 on the Y, and adding 15 on the Z. So we can do this here. So swap to victory view, character location.x is technically plus equals 0. So I'm going to take it out because I don't care about that. The Y was plus 600 when we're facing right. So plus equals 600. Then Z was 15. Character location.z plus equals 15.0f. Now, set actor transform. We're passing in the values that we determined here from the location. For the rotation, we have 0 on the X, 10 on the Y, negative 80 on the Z. So 0 on the X, 10 on the Y, negative 80 on the Z. You see scale is 1.0 all the way across. So character location, F vector, : 1 vector. That stays the same. Now let's go down to if is facing right returns false. We go here. We were subtracting 0 from the X location, adding a negative 600 to the Y location, which is the same as subtracting 600 from the Y location, and adding 15 on the Z. So let's go ahead and minus equals 600.0f plus equals 15. And let's make sure we update our values here. So character location.y minus equals 600.0f, character location.z plus equals 15.0f. Then we go to our transform, and we're passing in 0, 10, 80 for the rotation. 0, 10, positive 80. Then the same location and same f vector, 1 vector for the scale. Regardless of the branch result, if it's true or false, we still go and set the camera component's field of view to be 65. So after the if and else statement, get camera component set field of view to 65.0f. That means we can erase everything that's in this event in the blueprint. That means our base special camera BP has nothing in the graph, and since it has nothing in the graph, we don't need our player 1 and player 2 ref variables in here either. This blueprint is fine to keep. You can set default values on it. You can add more logic in here if you need, but now everything has successfully been converted to code. More cleanup we can do here. We can convert a lot of these to variables and consolidate some more logic, so you'll be seeing that very soon. Thank you guys so much for watching. Hopefully this video helped you convert your super camera from blueprints to code. If it did, please subscribe. It does more for myself and the channel than anything else you can do, and I really, really appreciate it. We just hit 10,000 subscribers, so thank you guys for all the love and support. If you want to support the channel, you can check out the Patreon, YouTube membership, or Discord subscriptions to do so, and you'll get some benefits while you're at it. If you ran into any problems while following this tutorial, or any of my tutorials, feel free to join the Discord community. There's a link in the description, and I would be happy to help you. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.